Hello, everyone, and welcome to your virtual presentation. I know you're super excited for science. Who's not? Science is awesome. Anyway, let's go ahead and get started. If you are at home and you are taking notes in your science notebook, if I start going a little bit fast, feel free to pause and press play when you're ready to go. If you're at home and you're taking notes or not taking notes because you left your science notebook at school, don't worry. It's going to be fine. I still want you to watch this video and listen to all those really cheesy things I make you do and say so you remember to do things and say things and all the fun vocabulary that is in this PowerPoint. Just because it sticks better in your brain if you get it a couple times, okay? So I'm still have you watch the video even if you aren't taking notes, and then once you get to school, I'll be able to, we'll get you to copy the notes in a different way, okay? Sound good? I'm assuming you said sound good because this is virtual and you're just watching this. All right, moving on. Okay, so we're going to talk about matter. You're matter. We matter. Everything is matter. So anything that has mass and takes up space or volume is matter. We basically think a lot of times that maybe gases don't take up space because we can't see them. And so we proved this on Friday when I blew up a balloon and you could see that in fact the gas did take up a space inside that balloon. We also have another experiment where we will measure to see if it has a weight. If gas can have a weight, it's not super accurate, so we won't know exactly how much it weighs, but you will be able to see it does weigh something. So basically, if something has mass and volume, it's matter. All right, so solid, liquid, gas, matter. All right, moving on to mass. Basically, the mass of an object is just how much matter is inside of it. If an object has more mass, then it's going to weigh more. And weight is determined basically by how much gravity is being applied. And so it can change if you go to different planets, for instance. I don't think that anyone has like a trip planned to Mars or something like that. But if you do, if you could let me know, I think it would be of much interest to your science teacher. But, think of me before you take a rocket ship anywhere. Anyway, moving on. We're going to measure with grams when we measure mass, mostly because we use the metric system in science class. We talked about this a little bit when we were measuring our plant's growth. Essentially, it's easier to work with, and also that's just what they use in science. So wherever you go in a lab, they will generally be using grams. So that's what we're going to use. We measure grams usually using a scale or a balance. And so I'm going to show you some examples of those right here. It says or. I'm going to just cover up the balance a little bit. Sorry, my head's real big. Anyway, so to find the mass, we're going to use a scale or a balance. So this right here is a balance. We will use those a couple of times in the classroom. Essentially, we'll use that mostly to compare two different objects, but you can use them to find the exact weight. We could find how many grams. I'm going to give you 1 second to think about it. How could we find the weight using a balance? You can pause the video if you're like, I'm going to figure this out before she tells me. Feel free. Okay, for those of you who are tired of watching me look confused and like touch my face, then I'll tell you. Basically, you put one object on one side, and then on the other side, you put weights. And so you can see how many weights it takes to balance it out. And then you know this object weighs this much. We will also use this little guy over here, and that's just called a scale. I'm sure you guys are familiar with scales. You might have seen them at grocery stores to determine how much money you got to pay for all those bananas. Or maybe you're at the doctor's office and you take your weight. Or maybe you are baking. Sometimes people use weights of flour and other materials for baking because baking can be very precise. And with measurement, you can get pretty good product, I've heard. I just still use cups because that's a lot. Anyway, let's keep going. Okay, so next we're moving on to weight, which we did talk about for a little bit. Weight is basically determined how strong the gravity is pulling on an object. That's how you decide how much something weighs. Something has more mass, it's going to have more weight. You can measure weight lots of different ways: pounds, tons, ounces, grams. Yeah, you'll hear it all different ways. Like I said, though, we're going to focus mostly on grams. So as you can see here, I'm going to introduce you to these prefixes right here. So we will be using grams. For small things, use milli, um, milli. So it'll still be grams, but we'll just put a different prefix in front of it. So milligrams is something that's smaller, whereas if we're measuring something a little bit larger, we're going to use kilo. So kilogram and milligram. As we keep going and I tell you the different ways we measure different things, liquids and stuff like that, you'll see that we still use the milli and kilo just in front of a new word. So milli, small; kilo, big; gram, grams; weight, grams. Okay, sounds good. All right, volume is our next one. When we're measuring volume, generally it is done in liters. We're essentially measuring how much space the matter is taking up. We will do a couple of volume labs in our classroom. We just do those using a little contraption, and then we put stuff in water to see how much space they've taken up. I know some of you may have done this in your class before, but it is important that you guys know how to read graduated cylinders and other measuring tools, because as you get older and get into bigger grades, you're going to need to use those skills when you get to lab. Okay, so I'm just trying to help you guys out so you're more prepared, and your science teachers will be like, wow, you guys are geniuses. Anyway, let's keep going. So we're going to use liter when we're measuring liquids, and you need to know this for the test. So this is a really cheesy way. I am not able to talk this afternoon. Goodness gracious. Anyway, so really easy way to remember that you always use liter for liquids is you put an L on your finger, and then you go liquid liters, liquid liters, liquid liters. You're like, that's weird. I know, but you need to do that to help you remember. So if you ever see me walk around the classroom, maybe while you're taking a test, I'm just doing this, remember that means liquid liters. So if someone says, you need to figure out how much orange juice is in this cup, what would you measure it with? Is orange juice a liquid? Definitely is. Going to be liters. Okay. You might also see people measuring with gallon, quart, ounce, pint, and a cup. Don't forget liquid liters. Again, we have those prefixes on there. So the milli is small and kilo is large. So milliliter for something tiny, kiloliter for something big. Woo! Look, I'm right in the middle. It's like, this is my show. Anyway, to find volume, has to use liquid, and you're going to use liters. These are graduated cylinders. No, they did not graduate college. I don't know why they are called that. If you guys Google it and tell me, I don't know. Maybe I'll have a fun surprise for you. We'll see. All right. So we will be using those in the classroom, and you can see all the different lines that we'll use to determine how much liquid is inside of there. So how many liters, milli or kilo. All right, so density. To find something's density, you just divide their mass by their volume. We won't get into the equation of it, but it's good for you guys to know that you can find density by dividing those things. Essentially, density is like how much stuff or the guts is inside, and you're like, that's gross that you use it that way. But there are many times that I'm going to say, think of the guts, and you'll be like, oh, for some reason, people remember the word guts and not stuff. I don't know. Just our brains, I guess. So if I ever say, think of the guts, you'll be like, oh, gross, density. All right, buoyancy. Buoyancy is basically how much something resists sinking. If it's really buoyant, then it won't sink. So I'm going to let you think for just a second. What is a word that looks and sounds kind of like buoyancy that reminds you of it? Can you think of it? Even if you can't, I'm going to tell you. Buoy. So think of a buoy. Think of those buoys that sit out on the water out there and they float around. they have a lot of buoyancy because they are floating, so they're not sinking. So a buoy has lots of buoyancy. All right. Next, for the next three, we're going to go through. You guys, I'm sure, have a pretty good idea about them. I'm sure you've reviewed it in other grades. Solids, basically, there's always going to be a definite mass. The volume is going to be the same, and the shape is going to be the same. So, like my chapstick here, we could weigh this. It's going to weigh a certain grams. It's going to take up the same space, and its shape is not going to change. So it's always going to be this solid. Let's move on. Liquids are wet, obviously, and take the shape of their container. So if I had some milk, for instance, and I poured it into a cup, it's going to take the shape of the cup. You could also think of, maybe I had like a crazy container that had all these wiggles and stuff in it. I could fill that milk, and that milk is going to fill up all the different divots and things like that, curves inside that container, because the liquid always takes that shape. And lastly, we have gases, and gases are just kind of like all over the place. They do not have a definite shape, or they don't have a definite mass. So basically, they can weigh different things. The volume is always different, and the shape is different. They also take the shape of their container. So yeah, we're gonna do one more for today. And oh, my head's gonna have to find somewhere to be. All right, we'll just stick me right there. Well, you can't really see it. All right, I'm going to be inside the liquid. Okay, so we talked a little bit about this on Friday, if you were here. So if you notice, the solids are all kind of stacked together, and they're not moving very much. They're just kind of stacked. The liquids are a little bit easier, breezier. They're not stacked. They're still kind of together, and they're moving a little bit more than those solids are. But as you can see, those gases are all over the place. So they're barely touching, and then they're like, whoa, and so they're moving quickly. All right. So your parents are probably thinking, what in the world is she doing in there, or he doing in there? That can't be science. Who's yelling like that on the screen? It's just me, science teacher. Sorry. That's what happens in science. So just remember, the solids are all stacked up really nice. The liquids are they're stacked up, but they're moving and grooving a little bit slower, and then the gases all over the place. Okay. All right. Well, I think that's enough of me making a fool of myself for one day. So remember, if you don't have your science notebook at home, it'll be fine. I promise. And if you do, just pause if I'm talking too fast. So you guys have a lovely rest of your day, and I will talk at you more on Wednesday. Bye.